Good day, students. I hope you're keeping safe. You're welcome to Golden Line School online physics class. Now, we'll be looking at calculation on resistors in series and parallel. Remember, in the last class, we talked about resistors, we talked about arrangement of resistors, and we did some calculations on resistors on series and parallel. Those calculations were simple calculations. Now, we are going to be looking at resistors that have combination of series and parallel arrangement, just like you have on the board. And then we're looking at the potential difference or the voltage across each resistors. Now, if you look at what I have on the board, I have two resistors in parallel connected to a resistor in series. Now, the question says, calculate the current I in the circuit. Now, this is the current that flows throughout the circuit. Now, for us to calculate the current that flows throughout the circuit, the first thing you have to do is you first of all calculate the effective resistance in the circuit by saying, let's start from the resistors of that in parallel. You have 1 all over ROT is equals to 1 all over RO, 1 plus 1 all over ROT equals to 1 all over 4 plus 1 all over 6. You find the LCM of 4 and 6, that will give you 12. Now 12 going 4 will give you 3. 3 times 1 is 3 plus 12 going 6 will give you 2. 2 times 1 will give you 2, so that you have 5 all over 12. Remember, for resistors in parallel, you don't leave your answers like this. Now you do the inverse. So if the inverse, you have 1 all over ROT equals to 5 all over 12. Now if you do the inverse of 5 all over 12, you are going to get 12 all over 5. So therefore, ROT is equals to, now 12 all over 5, if you divide, will give you 2.4. So that's not for that. Now, this resistor is now, these two, they are now combined, they give you 2.4. Combined to this, which is 10 ohms. Now, from here, you have resistors in series. Now, for resistors in series, you have ROT is equals to R1 plus R2. That will give you 2.4 plus 10. That will give you 12.4 ohms. So you have 12.4 ohms as the effective resistance. Now, we are looking for the current, right? Now, using the formula from Ohm's law, where you have V is equals to I R. Since you're looking for current, you make isolate of the formula, it becomes I is equals to V all over R, where your V in this circuit is 12 volts, right? So you have 12 divided by your effective resistance. Now, that will give you 12.4. So, from this place, when you divide, your I becomes equals to 0.967, which is approximately 0.97 ampere. So this becomes your answer. So that's for number 1. Number 2 says, determine the potential difference across the parallel resistors. Now we want to find the potential difference in this place. Remember, the potential difference across this resistor will be different from the potential difference across this. So if this is V1, this will be what? This will be V2, okay? So the potential difference across this will be calculated using the effective resistance of this place. Now from here you have, so for number 2, where you use the formula for Ohm's law, which is V is equals to I R. Now remember, your current that you got is 0.967 ampere, and then if you check times, yes, the resistance you are going to use at this point is the resistance you got from this place when you calculated, which is equals to 2.4. This becomes 0.967 times 2.4. Now you might be asking me, sir, why didn't I use all the resistors? Now the reason why all the resistors is not used is because the question said determine the potential difference across the parallel resistor, which is this. If they say determine the potential difference across this 10 ohms resistor, then you use this one. So let's continue. So when you multiply this, you are going to get 2.328, okay? So this is close to your answer. So this is approximately 2.3 volts. So your answer is B. Now, on that note, if you are asked to calculate the potential difference across this, like I told you, you are going to have V is equals to I R. So it becomes 0.967, which is your current, times your resistance, which is 10 ohms. So if you do that, that will give you 0 point, no. So 10 times this will give you 9.67 volts. Now if you do, let's call this V1 and let's call this V2. Your VT, if you do your V1 plus your V2, you would have a value of 12 volts, telling you that 12 volts is shared between this and this. So that is how you calculate your current, your voltage in resistors. Alright, so I hope you have learned the calculations on resistors in series and parallel, and how to calculate a combination of series and parallel. So your notes will be uploaded on the Golden Line ISM portal, so do ensure to download your notes and study. And if you have any question, please you can send your comments or your question to the WhatsApp group. Thank you.